So here is what Dadu or
And any idea what kind these?
2, 3. See, this is all the one. Cool.
We prolonged the time that the parasite needs to be inside the mosquito in order to be transmitted.
To work because there's no seasonality, so respecting people accept well. So that's
The important thing that we have to understand is that the mosquito is not just a mere carrier of the parasite. It doesn't take it from one human infected and carries it to another one. The parasite needs to spend time in the mosquito, and it has to develop. It's like development of an organism. It has to develop from initially gametes, like a sperm and an egg, into a zygote, like the embryo, and then becoming a cyst. And then inside this cyst, we have some new parasites forming that will infect the salivary glands of the mosquitoes, so that when it bites again, these parasites in the salivary glands will be ejected into the new person. And this period, this developmental time takes about, in nature, about 10 to 12 days. So what we did here is to prolong that, make it longer. So instead of 10 to 12 days, it would be like 15 to 17 days that would take for the parasite to become infectious for another human inside the mosquito. Now, why is this important? Because mosquitoes in nature usually live short. They have a short life. An average mosquito in nature will live about 7 to 10 days. So it doesn't have enough time to transmit the parasite. So most mosquitoes will never have the chance to transmit the parasite. It's only 10% of the mosquitoes out there that live long enough to be able to transmit the parasite. By prolonging the life, the developmental time that the parasite needs inside the mosquito to become infectious, it means that this 10% becomes now much smaller. It's only a very tiny fraction of mosquitoes that can live long enough to transmit the parasite. The other thing at the same time that we managed to do is that we cut the mosquito life a bit short. So instead of living 7 to 10 days on average, it will live a bit shorter. So the two things combined together now can lead to blocking malaria transmission in the field. So this is the innovation. This modification that we did makes them weaker because they live shorter. So it would be eliminated naturally by the natural selection. After a few generations, they will be eliminated. So there's no way to spread this modification in the field unless you combine it with what we call the gene drive, which is not what we, I mean, we have tested it here, but we have not really put it in its full implementation. So what you do is you combine this genetic modification with a driver, what we call a driver, which will take this modification and spread it quickly through the populations. Now, the details of how this is done doesn't matter, but essentially it drives it through. So within a few generations, all the mosquitoes in the field, in an area where you release, they will become genetically modified. This is the thing that scares more the people at the moment, the gene drive.